guys. I'm sorry I'm not here with you to explain this face to face or camera to camera. But anyway, this is just a little introduction to the topic that we're going to see. I know you remember this from 6th and 7th grade, mostly from 7th grade. But we're going to be working with probability, okay? At the beginning or in this video, which is introduction, you're gonna feel like you are re-watching or you are relearning the same thing that you learned, but it's just the introduction. I'm gonna try to explain some different concepts, but that's gonna be tomorrow, okay? Listen up. We're gonna start by identifying the independent and dependent events. I'm sure that you have a clear idea about this. Let's just see if you can remember more. What is an independent event? It is an event or events that are not affected by previous event. That is, the fact that you do something or an experiment does not affect the second result that you're going to get in the same experiment. For example, what is the probability of getting a 4 and a 6 when I roll 2 die? So imagine you have these 2 die and you want to find out that those probabilities. First, on the first die, I need to get a 4, and on the second die, I need to get a 6. What are my chances of getting a 4 on the first die? That is 1 out of 6 because I only have 1 4 and I have 6 numbers. Then, what is my probability of getting a 6 on the second die? My probability is the same, is 1 out of 6. Remember that probabilities are multiplied, okay? So I just need to multiply 1 times 1, which is 1, and 6 times 6, which is 36, and that is my probability. That means that the chances of getting a 4 on one die and a 6 on the second die are 1 out of 36. And that's it. I'm sure you can easily understand and identify the reason why it is an independent event. The reason is that the first event or the first try that I did, which was getting a 4, didn't affect the fact that I get in the second one a 6. They were not connected, thus they were independent events. Now, dependent events. Listen up. The definition is obviously the opposite one to the other. Guys, I'm scared that I'm not recording this. No, I am recording. Okay. So the dependent events are the opposite, the ones that are affected by the previous ones. This is a deck of cards, okay? I'm sure that some of you already have an idea of all the cards that compose this deck. And you have numbers from 1 is an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have a jack, you have the queen, and you have the king, okay? And then you have clubs, diamonds, hearts, and spades. Now, imagine they give you this experiment and they tell you, I want to know the probability of not picking a face card. Guys, a face card is the card that has a face, like a jack, a queen, or a king, which are people on the cards. Those are the face cards, these ones. So what are your chances of not picking a face card and then picking a face card? Listen up. You have some instructions here. It says, once you grab a card, you won't replace it, okay? If I grab one card, I won't put it back to the deck. So, what are my chances of not picking a face card? How many of these 52 cards, because there are 52 in total, how many of these 52 are not face cards? Well, all of these are not face cards, which are 1 to 10 and 4, it's 40. So my chances of not picking a face card are 40 out of 52, because if you count all of these cards, are 52. Now, imagine that you already grab a card that is not a face card. So now, imagine that card was this one, okay? What are your chances of picking now a face card? I have 12 face cards, so it's 12 out of 52 or 51. If you said 52, you need to rethink that. It's 51. Why 51? Because you already grabbed a face card. You already grabbed a card that is not a face card. And it says that you grab it and you don't replace it. You don't put it back. You already grabbed this one. So it's 51. The reason, guys, what you need to identify this as an dependent event, not independent, but dependent, is because what I did in the first try, what I did here, actually affected my second probability. What did affected that? Because I already grabbed a card. Of course, that is gonna affect my second result. Now I just need to multiply it, and I'm gonna do it right now. Remember that in this topic you're not supposed to use the calculator. Anyway, I'm gonna use it in a few minutes. So I'm just gonna multiply 40. Well, 12 times 40, which is the same, is a 0. 4 times 2 is 8. 4 times 1 is 4. 480. And then I'm gonna multiply 52 times 51, which is 2, and 5 is the space. 5 times 2 is 10. 5 times 5 is 25. Plus 1 is 26. I just add them, and that is 2,652, and that is your probability of getting them. Yeah, the only thing you need to identify is the fact that what is a dependent event and what is an independent event. Now remember that these fractions need to be simplified, so instead of doing all the procedure, I'm just gonna go here, and in fact I had already opened the thing, so it's gonna be 180 over 2,652. I'm gonna simplify it, and that is 40 over 221. 40 over 221. I cannot simplify this thing anymore, and that can be your probability expressed as fraction. You can express it as decimal too, which of course requires you to divide this thing, or as percentages, but I guess right now we're gonna be working with fractions mostly. Okay, and that's it. That's the main thing I want you to remember. Tomorrow we're gonna see the new concepts. I guess, or I hope that until this point you understood everything that I said. Now it is your time to work by yourself. You are gonna work on 2 IXLs. They're gonna be from 8th grade, and they're gonna be EE. I don't remember the EE. Wait, it's EE9. And let me see the other one. Sorry, technical issues, I guess. Oh, it's not charging. No, I already charged. It was I said EE9 and EE8. Yeah, EE9 and EE8. Those are the ones. Okay, it closed anyway. EE9 and EE8 until 70. Okay, and that will be it. Thank you so much for watching this thing. Don't forget to do them until 70, and I hope I can see you in a few minutes to tell you how I am. Love you guys.